All right, all I really want to do in this video is highlight a couple of useful tables that you have in your book. So I'm going to mention table D1 and I'm going to mention table D2. So table D1 deals with physical properties of some common materials. We deal specifically with the density, which is usually reserved for SI problems, and then specific weight, which is usually what is used for US problems. So density is a mass per unit volume. Specific weight is a weight per unit volume. And I just want to highlight that the table lists these two values for various materials that you would commonly encounter, specifically in mechanics courses, but these are pretty common all around. So that's all I'll say about that. Make sure you're careful to look at the right column depending on the problem you're working. If you're in a metric problem, then obviously you're going to stick with the kilograms per meter cubed and the density column. And if you're in a US problem, you're going to be looking at the specific weight. Usually density is referred to with the symbol of rho, Greek letter rho, and specific weight is referred to with the symbol gamma, the Greek letter gamma. Table D2 lists a lot of solar system constants, and so a couple of the things to point out in here. We have the gravitational constant. We mentioned that when we dealt with our law of gravitation video. We also have the mass of the Earth in both kilograms and slugs. Note that they don't write slugs. Slug is not a base unit. Period of the Earth, angular velocity, some of those things. Not a lot of stuff here that you're going to be utilizing in this course necessarily. One thing that would be used is the mass of the Earth. This is pretty common, especially if you're asked to do a celestial sort of calculation of gravitational force of attraction if you're not on the surface of the Earth. Remember, when we dealt with apparent weight, W is equal to mg, that is really on the surface of the Earth. That's how that was fleshed out. If you're far out in space, then the force of attraction would be equal to the weight, but it's g m1 m2 divided by r squared, and here m2 would probably be the mass of the Earth, and r is going to be the distance you are from the center of the Earth. So that could be pretty significant. And what you see down here in this table are the different celestial bodies, sun and moon, and then some of the planets that are of use. We don't, have all the planets like Saturn and so forth. Stop out there at Jupiter. But we have the distance to the sun given here in this first column. Notice it's in kilometers and then in miles here in parentheses, except in the case of the moon. We don't really care about how far the moon is from the sun, and this number 1 means the mean distance to the Earth. Orbit eccentricity is not going to be something you use here. You're not going to use the period of the orbit for this class. Mean diameter, you might use that. This shows up more in dynamics class. So if you take that one, this will show up some. Mass relative to the Earth. So for instance, the sun is 333,000 times as massive as the Earth. So if you wanted the mass of the sun, then you would take that number and multiply it by 333,000. So a healthy number. All right, the moon is smaller, Mercury and Venus are smaller. The Earth is obviously a ratio of 1 because it's to itself. Then Mars and Jupiter. Surface accelerations of gravity. I'll just mention this for the Earth simply because these numbers are a little bit different than the ones I gave you. So these have a little bit more involved. These are accepted values for a non-rotating spherical Earth at sea level and a latitude of 37.5 degrees. So I gave you values of g equals 9.81 meter per second squared or 32.2 feet per second squared. Use those values unless you're told otherwise. And then you have the escape velocity, but you're not going to do anything with that in this class. All right, so that's just 2 useful tables. We had already covered table D5, which dealt with conversion factors. Spend some time in the appendices of your textbook. There's always a lot of good information to be found there. And I'll stop there. All right.